When building an agent, the core task is to apply intelligence to a problem by breaking it down into smaller steps that can be executed in sequence. In other words, many agents can be described as workflows, a chain of reasoning, decisions, and actions. Because workflows can be nicely constructed visually, the agentic ecosystem has started to produce visual agent builders that let us design these flows directly on a canvas. These tools support no-code and low-code agent creation. That means non-developers can build agents without writing code, and developers can focus more on architecture, logic, and workflow design rather than plumbing or boilerplate. So, agent builders are not just for beginners, they are also extremely valuable for experts who want to prototype faster, experiment with different designs, or collaborate with non-technical teammates. In this video, we'll explore some of the most important visual agent builders and see how our agentic concepts like tools, planning, actions, and memory appear inside these platforms. There are two main ways to build agentic systems today. The first approach is code-based. Here, developers use APIs and SDKs to define prompts, tools, memory, and workflows directly in code. This gives maximum flexibility and control, and is ideal for deeply customized systems. The second approach is visual. With visual builders, we design agents using graphical interface, blocks, and workflow canvases. This removes much of the boilerplate and makes agent creation faster, more collaborative, and accessible to non-developers. Both approaches are valid, and in practice, they are often complementing each other. A team might prototype an agent visually, then move to code for advanced logic, or maintain both paths for different use cases. In this video, we'll focus specifically on the visual approach and look at some example platforms that support it. OpenAI provides a full visual agent builder as part of AgentKit. It's a drag-and-drop canvas for creating AI workflows without writing code. You build agents by connecting nodes such as agent nodes with system instructions, branching logic, if else, while, tools like file search, code interpreter, or MCP servers, and data transforms and state updates. You can prototype entire agent workflows visually, test them using the built-in preview, and even add custom widgets for rich outputs. When the workflow is ready, it can be published directly as a deployed agent and used either as exported agents SDK code or integrated into a product using a workflow ID for ChatKit. So OpenAI Agent Builder bridges no-code and code. Non-developers can design complete agents visually, and developers can extend or integrate the same workflow in software. Flowise is an open-source visual builder for creating advanced LLM-based agents. It can run self-hosted or in the cloud and supports many model providers, including OpenAI, Anthropic, Google Gemini, and even local models via Llama. With AgentFlow v2, Flowise introduces a single visual canvas where we can design a complete agentic workflow using drag-and-drop blocks. Flowise includes many node types, but they can be grouped into a few important categories. 1. Agent nodes. These are the reasoning steps. We choose a model, add system instructions, attach tools, enable memory, or route results to another part of the workflow. 2. Logic and control nodes. These determine how the workflow behaves. Conditional branching, routing using another agent, looping, iteration, or asking a human for approval. This is what makes a workflow dynamic instead of linear. 3. Tool and integration nodes. These allow the agent to act in the real world, calling APIs, executing code, connecting to databases, performing retrieval, or using MCP tools. This is where the agent stops just answering and starts doing. 4. Memory and knowledge nodes. Flowise can store persistent memory or retrieve information from vector databases and document stores, which supports stateful conversations and grounded responses. In the example on the slide, user inputs enter through a start node, passes through a detect user intention step, and is routed to different specialist agents depending on the classification result. For example, a technical agent using Gemini, a sales agent using Claude, or a general agent using GPT-4 Mini. This visually demonstrates how Flowise can orchestrate multiple LLMs inside a single workflow, each one specialized for a different task. And because Flowise is open source and API driven, the same workflows can be deployed into real products, backend systems, or automation platforms, making it a flexible foundation for production-ready agentic applications. Flowise doesn't just let us place a single agent on a canvas, it supports full coordination patterns between multiple agents using Agent Flow v2. We can design how agents interact, route tasks, and refine answers across multiple steps. These are some of the most important coordination patterns that Flowise supports visually. Chaining. One agent hands its output to the next, useful for multi-step reasoning or transforming an answer through several specialists. Parallel execution. Multiple agents or tools run at the same time, for example, a web search, a retrieval agent, and a summarizer, before merging into a final response. Routing. A router agent decides where to send the query, for example, billing, technical support, or general help, based on user intent or classification. Iteration. An agent can loop through a task repeatedly, such as researching multiple sources or refining information until a condition is met. Looping, or self-correction. The workflow can loop back when a result isn't accurate or complete. This enables error correction or quality improvement steps. Hierarchy. A supervisor agent manages several worker agents, such as a planner, researcher, code reviewer, or writer, and organizes the workflow. These patterns map directly to the multi-agent concepts we discussed earlier: reflection, planning, sequential flows, and hierarchical coordination, but now implemented visually inside Flowise. Automation platforms such as N8N and Make.com have been designed to connect different services and APIs through visual workflows. They allow actions like sending data to other systems, triggering webhooks, posting to communication tools, updating Google Sheets, and more. With the introduction of LLMs, these platforms now offer nodes for calling AI models and using model outputs to introduce workflow decisions. This has led to their positioning as AI agent builders, because agents often require workflows and connections to external systems. N8N is available as both open source and cloud-based, while Make.com offers only a cloud-based environment with a large library of integrations. While these platforms were not originally built as AI-first orchestration tools, they can support agentic systems when integration with external applications or services is required. In practice, An LLM can interpret an instruction, and the automation platform can carry out the resulting action by interacting with third-party tools. So automation platforms are becoming part of the broader agentic ecosystem, especially when agents must interact with real-world systems, business tools, or APIs. LangFlow is also another visual development environment built on top of LangChain with many similarities to Flowise. It provides a drag-and-drop canvas where we can create LLM pipelines, agents, and retrieval workflows without writing code. Each block represents a LangChain component, models, prompts, retrievers, tools, memory, or custom Python functions. By connecting these blocks, we can prototype complex agents quickly and then export the workflow as code for production use. What makes LangFlow especially useful is that it exposes LangChain's building blocks visually. Flowise does this too. So instead of first learning all the Python APIs, users can experiment with chains, tool calling, routing, document retrieval, vector stores, or prompt engineering directly on a canvas. LangFlow is open source, can run locally or in the cloud, and integrates with many providers, including OpenAI, Anthropic, Google Gemini, and local models through Ollama. In short, LangFlow sits in the LangChain ecosystem as the visual layer. It helps prototype and reason about workflows faster before turning them into code or deploying them. We will learn more about LangChain and its ecosystem in the next video. In this video, we looked at how visual agent builders make it possible to create agentic workflows without writing code. We saw that platforms such as OpenAI Agent Builder, Flowise, LangFlow, and automation platforms like N8N or Make.com allow agents to be constructed as workflows by connecting nodes that represent models, tools, logic, and actions. These platforms support no-code and low-code development. Non-developers can build agents through a visual interface. Developers can focus more on workflow design, testing, and iteration. While Agent Builder, Flowise, and LangFlow are AI-first platforms, automation tools like N8N and Make.com can integrate LLMs into broader automation pipelines or business processes. Together, these tools show how agentic systems are moving forward visual modular design, where reasoning, tools, memory, and actions can be arranged on a canvas and deployed into real applications.